In this example, we have that a random sample of 2,400 items has a confidence interval that estimates a population proportion with a lower bound of 0.33 and an upper bound of 0.65. So we're looking at an interval. I'm going to make it on a number line so we can visualize this. Our lower bound is 0.33, and this is a proportion, which basically means we're looking at percentages in decimal form. So this represents 33%, and then I have 0.65, which represents 65%. So someone did a study, and they didn't really put any context in here. So imagine that you have some characteristic that you're checking for in these 2,400 items. You're checking for some specific thing. When you count all of the items that have that characteristic out of the 2,400, you come up with a proportion or a percentage. That will be what we call our sample proportion, because it's our proportion that we get from the sample, and that's what we use to estimate the entire population. So that proportion is going to go in the center. And a lot of times statisticians will label that P with a little arrow on top of it, and that's P hat. So this is a sample proportion. Now, then the person will create and calculate an error. How much error do we want to give ourselves? So from that guess, from the sample, we will add or subtract from that center an error to give us that cushion. In this case, we have our center, which is our sample proportion, and then I add something to get the high value. I add something to get 0.65, and then I subtract something to get 0.33, and that's our error. That's what helps us create our interval. The P hat is our guess from the sample. The error, when we add and subtract it, will give us our interval. So the first part of this question says find the sample proportion. That's this value right here. We don't know what it is, but we have enough information to figure it out. The proportion is going to be what's in the center of this interval. So we're going to take 0.33, add it to 0.65, and divide by 2 to find our center. When we do that, you're going to find that the sample proportion is 0.49. That is the center of our interval. So that means 49% of that 2,400 items had that characteristic that we were looking for. So that would be the 0.49. Now, the question says, what's the margin of error? That's our cushion. That's what we add and subtract from the center to create that interval. So to figure out what that error is, we just need to find the difference between the center out in either direction. Now, it should be the same in either direction, so it doesn't matter if you choose to find the difference between the center in the lower bound or the center in the higher bound. When you find the difference between the center and the lower bound or the center and the higher bound, you're going to find that that difference is 0.16 or 16%. So the cushion that this person gave themselves to create this interval was a cushion of 16% error. So they took the information that they found from the sample, which was the proportion of 0.49, they added and subtracted 16% or 0.16 to both sides, and that's where we get the lower and the upper bound of our interval. Our margin of error, we would say, is 0.16. Now, the last part of this question says, what is the number of items with the characteristic of interest? So, if we know that when we took 2,400 items, we found that 49%, or when we look at it as a decimal, 0.49, we found that 49% of that 2,400 had the characteristic that we were looking for. So if I want to find out how many that is, I just got to find 49% of 2,400. So that would be 0.49 times 2,400 And when we calculate that, we get 1,176.